Hello everyone. I'm giving some series of lecture for the course probability and statistics. And in the last two lecture, we have discussed few example. We'll continue few more example with this lecture, right? So let us see this example. A discrete random variable z has the following probability mass function. So the probability mass function is given. You have to compute that E of expectation of 3z square minus 2z. Now this one you can do it in a two way. One is like you can directly write this is equal to 3 into E of z square minus 2 into E of z, expectation of z. So you can do it in this way and then you individually find out E of z square and E of z and put it and you will get the value. And you can do it in another way also, because you know that some formula we know that expectation of some function, maybe g of capital Z, it is equal to summation of gz into pz, right? Summation over z. So we know this formula as well, correct? So we can apply this formula where pz, p of small z is p of capital Z equal to z, that is the probability mass function. So we can apply this formula and then we can do. So anyways, fine. So I'm doing it in the second method, and let's see then what is the values of that gz value. Now what is the g of suppose g is equal to gz here. What is gz? Gz equal to pz square minus 2z, right? So g of 1, what is that value? It is 3 minus 2, it is 1. G of 2 is what? It is 3 into 4 minus 2 into 2, it is 8. Like that we can find the value of other value. So g of 3, 3 into 9 minus 2 into 3, 27 minus 6, it is 21. And g of 4 equal to 3 into 16 minus 2 into 4 is equal to 40, right? So the expectation of this value is what? Then finally we can just get it, that expectation of pz square minus 2z is equal to then g1 into p of 1, right? So we should write it as g of 1 into small p of 1 plus g of 2 into small p of 2 plus g of 3 into small p of 3 plus g of 4 into small p of 4. So we can do it in this way, and just if you put the values, we will be getting the answer. So g of 1 is 1 into p of 1 was 1 by 8. G of 2 is 8 into p of 2 is 1 by 4. G of 3 is equal to 21 into p of 3 means 1 by 2. And finally g of 4 is equal to 40 times p of 4 is 1 by 8. Right? And then just if you simplify it, you'll be getting this value is equal to, like you just simplify, you will get the answer. Right? Mostly you will be getting 17.625. So we can easily find out, or just we have used this formula, and you can directly also do like, because it's a linear type, and then you can do E of z square and E of z separately and put it in the value. I hope it is easy, clear. Let me move to the next example. Yeah, this is another example where expectation of y and variance of y is given, and you have to find the expectation of some another expression. So how to do that? What we can do? Let's see. So expectation of this 3 minus y whole square. It is what? So you just defactorize. It is 9 minus 6y plus y square. And according to the expectation formula, this is 9 minus 6 into expectation of y plus expectation of y square. Now we have this value, but we do not have this one. So we have to calculate expectation of y square. How to calculate? So we have to get it from the variance formula. How? See, we know that variance of y is equal to expectation of y square minus expectation of y whole square. So we know this formula, right? So then we can put the value, whatever we have, and then from that we can get expectation of y square. This is equal to variance of y plus expectation of y whole square. Now what is this value? Variance is given as 3 plus expectation of y is minus 2 whole square. So it is 3 plus 4, it is 7. So expectation of y square, we got it at 7. And therefore, what we will get for this one, and therefore we can have expectation of 3 minus y whole square is equal to 9 minus 6 into expectation of y was given as minus 2 and plus expectation of y is 7. We already calculated, and this value is equal to 12 plus 9, 21 plus 7, 28. I hope it is clear. And the next example, yeah, if you see the next one, like this is the first part we have done, and the second part is you have to check the variance of 2y minus 1. Now regarding variance, we have another property of variance. We have seen that it is variance of ay plus b is equal to what? It is a square times variance of y. We all know this form, right? We have proved it in our theory class, one of our lecture. And therefore, because it is like in this case, b do not have any role in case of a variance. So therefore, if I apply this formula, then I will get variance of 2y minus 1 is equal to 4 into variance of y. Now what is variance of y? It is given as 3. So 4 into 3, it is 12. Clear? Okay. Now a few examples. Now in discrete type random variable, we have discussed 4 different type of random variable. Mainly, one is binomial, one is Poisson, geometric, and negative binomial. Right? So we will solve few example of this kind, and we'll identify which problem is of which type. So once you identify the problem, after that it is very easy. You will understand that you just have to put the formula and you will get the answer. Let us see this example. A fair die is rolled 5 times, and let x be the number of times a 6 appears. Now x is a random variable, and what it says, it is the number of times 6 appears. The phase 6 appears. Compute the probability that exactly 2 sixes appears. Now this one is like x is the number of times a 6 appear. And that means whenever you think that a 6 will appear, you will think it as a success, right? And how many times a die you are rolling? It is 5 times. So you have find 5 number of trial, actually Bernoulli trial, where you have only each trial you have one success, one failure, only success and one only failure. What is success? Success is if you get the phase 6, and failure means if you get other phase. So in this case, probability of success is what? The small p. So in a rolling a die, the 6 will appear. What is the probability of that? That the phase 6 will appear? Yes, it is 1 by 6. So this is the probability of success. So now this kind of trial with the probability of success p, you are doing 5 times, right? And then you have to find out that some specific number of success you have. So what kind of distribution x will follow? Right? So x is a binomial random variable. Correct? So x is actually a binomial random variable where the number of trial is 5 and probability of success is 1 by p. So we know that binomial NP, right? So binomial, we can define it as binomial. N is equal to what? N is equal to 5 and p is equal to what? P is equal to 1 by 6. So it is a binomial random variable x. Now we all know the probability mass function of it. What is the probability mass function of the binomial random variable? So mass function is equal to p of x is equal to k is equal to nck p to the power k into 1 minus p whole to the power n minus k. And what value k will take? K takes the value 0, 1, 2 up to n. Right? Now the first answer. The probability that exactly 2 appears. That means what? That k equal to 2. Right? Here your n is 5, p is 1 by 6 and k equal to 2. Just put it in the formula, you'll get the answer. P of x is equal to 2 is what? NCK, so 5C2. P means 1 by 6 whole to the power 2. 1 minus P means 5 by 6 whole to the power n minus k. That means 3. This should be your answer. 5C2, 1 by 6 whole to the power 2 and 5 by 6 whole to the power 3. Right? And just if you simplify, you will get the final answer. Right? I am not going to that detail. You can just use your calculator and you can finish the problem. Okay, the answer for the next one. The expected number of success. That means what? The expected number of success you have to get. That means expectation of x you have to calculate. Right? Now that expectation of x in case of a binomial random variable, what is the expectation formula? We all know it is n into p, where n is the number of trial and p is the probability of success in each trial. Now what is n here? N is 5, p is what? 1 by 6. Therefore the expectation is 5 by 6. So this is the expected number of 6. Clear? And then the final one, the variance of x. Now again, for the binomial random variable, the variance formula is npq, right? Variance of x is equal to, it is npq and it is basically n into p into q means 1 minus p. So what is that? So 5 into 1 by 6 into 1 minus p means 5 by 6. Right? So it is 25 by 36. And you may take the decimal part of it by using the calculator. So I hope you understand. So whenever you have the finite number of trials and you have each trial, either it's a Bernoulli trial, that means you have either failure or success, then the probability of getting exactly 2 numbers, 3 numbers, any k numbers, it will definitely follow the binomial random variable, right? So you can understand from this. So finite number of trials, from that you have to get some specific number of success. Then it will follow the binomial random variable. Right? So if you understand this one, can you please identify this problem? A quality control inspector finds that 50% of items produced by a machine are defective. Right? So 50% items produced by the machine are defective. If 8 items are randomly selected, what is the probability that exactly 2 are defective? Now again, that means what? Your items are either defective or perfect one, right? So either you will get a, whenever you will select some item, it can be defective or not defective. So it is either success or failure. Here probability of success means probability of getting the defective piece. And what is that? Probability is 15%. That means 15 by 100. And here how many items you are selecting? 8 number of. That means you will have 8 trials. Each time your probability of getting a defective piece is 15 by 100, right? And then you have to find the exactly 2 are defective. What is that probability? Definitely again this will follow the binomial random variable, this distribution, binomial distribution, and you can easily understand. So p equal to this, here n is equal to 8 and you have to get k is equal to 2. So how to get that? For if I just apply the binomial random variable, then mass function formula, it is p of x is equal to 2 is equal to nc2, so 8c2 p to the power 2, so 15 by 100 whole square into 1 minus t, so it is 85 by 100 whole to the power 6. This will be our required answer, and you simplify it and you will get the final, right? So again, this one followed the binomial random variable and binomial distribution. Now we have another one. We have another question. Let's see whether you can identify which random variable it will follow. A multiple choice quiz has 10 questions, each with 4 possible answers. A multiple choice quiz has 10 questions, each with 4 possible answers. Multiple choice means what? It's you have actually one correct answer among the 4 options, right? You have one correct answer among the 4 possible answers, 4 choices. Now, if a student guesses randomly on each question, what is the probability that they get exactly 3 questions correct? How you have to do? Understand again, you have 10 questions, right? So each of them are multiple choice question, each having 4 options, one is a correct answer. So probability of getting success is what? Probability of getting the correct answer. Now can you tell me what is the probability of success here? So one option is correct, so it is 1 by 4, right? So probability of success P is equal to 1 by 4. And then after that, you how many questions you have? 10 number of questions. So your n is basically 10. And then you have to find the three number of success probability. So your k is equal to 3. So then here this random variable x is a binomial NP. So bin binomial n is equal to 10 and p is equal to 1 by 4, and then you have to find p of x is equal to 3. So just put it in the formula. We have already done this kind of problem. I'm not going into the detail. I hope you got the answer. You can easily get the answer. So you will get this value after putting the formula. Now look at the second question. Using the information from part A, what is the expected number of correct answer and what is the variance? Again, we know that expectation of A is what and expectation of this is what. So part A was this. Expectation of X is N into P and variance is NPQ or NP into 1 minus P. So just put them in the formula, you'll get the answer. Right? So all these 3 problem we have done, all of them follows the binomial random variable. All the random variables are binomial random. Okay, now let's move to the next question. A small bakery observed that customers arrive at an average rate of 6 customers per hour. What is the probability that exactly 2 customers arrive in a 15 minutes interval? Now see, this is the one we discussed during our Poisson distribution time, right? That we have seen that the Poisson random variable follows a probability mass function that with a parameter lambda is e to the power lambda, right? E to the power minus lambda into lambda to the power k divided by k factorial. We know this Poisson random variable will follow, and we also know that lambda is actually the parameter lambda is actually the average value or its expectation, right? And look at this problem. A small bakery observed that customer arrives at an average rate of 6 customers. So they know that average thing per hour 6 customers, but at a particular hour you may have 0 number of customers also, right? At a particular hour you may have a very large number of customers as well, whereas average, you know, by checking the maybe the statistical data or somewhere, you have understood that average is 6 customers, but this can have that number of customer can be 0 to a very large number also, so 0 1 2 3 up to any number. So average we know, and we have to find a that exactly some particular number of customers arrive in a some particular time interval. So definitely it will follow the Poisson random variable, right? Poisson distribution. So in case of a Poisson distribution, we need to know the average value or the expectation, which is the parameter lambda. Now here in the question it is given that 6 customer per hour it is given. Average value is 6 customer per hour it is given. Whereas in the question it is asking that 15 minutes time interval. So we have to get the average in 15 minutes interval, right? So in an hour, 60 minutes you have 6 customer. 60 minutes you have 6 customer. 1 minute you have 6 by 60 customer. And therefore in 15 minutes how many customer you will have? 6 into 15 divided by 6. Right? And then therefore this new lambda, new expectation within the 15 minutes time interval, that new parameter is this one, so it is 1.5. Now after that it is very easy once you understand. Now what is the probability mass function for the Poisson random variable? Right? The PMF of x. So this is a Poisson random variable. X follows. X is a Poisson random variable. Poisson random variable. And we all know that a Poisson random variable PMF is P of x is equal to k is equal to e to the power minus k, right, into lambda to the power k divided by k factorial, where k is equal to 0, 1, 2. It can be a very big number. Now what is lambda? Lambda is 1.5. And what is the question? You have to find that 2 customers arrive in a 15 minutes interval. So you can easily answer P of x is equal to 2 is what? It is equal to e to the power minus, actually it is e to the power minus lambda, right? I have written k. So again it is e to the power minus lambda. So it is minus lambda is 1.5 into lambda to the power k, 1.5 to the power 2 divided by k factorial, it is 2 factorial. And just after doing this simplification, you can get the answer. Clear? Now, let me see the next example. Next example is an email server receives an average of 10 emails every 5 minutes. What is the probability that it receives exactly 5 emails within a 2 minutes time period? Now, if you see this example, is it not the similar type? Right? So in 5 minutes, you know the average. So in 2 minutes time period, you have to find its average. So expectation in that new random variable. And after that, it will follow the Poisson random variable and you put it in the formula, you get that. So the next question was this one, and you can easily get the answer. Hope it is clear. So the 16th question, maybe I can just give you the correct answer, like just a hint. After doing this, you should be able to get that this answer P of x is equal to 5 is equal to, you first you do it and you match with this answer. It is 4 to the power 5 e to the power minus 4 divided by 5 factorial. You should be able to get this answer. So the 16th one, you do it and check whether you are getting this answer or not. Okay, let me move to the next one. Look at the problem number 17. A pharmaceutical company is testing a new drug, and the probability that the drug causes a side effect is 0.02. If the company tests patients one by one until a patient experiences a side effect, what is the probability that the first patient to experience a side effect in the fifth patient tested? Now try to identify the problem, that which kind of distribution this random variable will follow. Right? So here the number of patients tested until the first side effect follow which kind of distribution? So suppose x is an interim variable that counts the number of patients tested until the first side effect follows. So try to recall the geometric distribution. What was that? You will do the Bernoulli trial until you get a success. Remember? So you will do the Bernoulli trial until you get a success. So is it not like that? So it counts that time the random variable was counting the number of trials to get the first success, right? And here it is the same thing. So you have to find like you have to understand this is actually follows the geometric distribution with probability of success is what? Probability of getting that patient will have the side effect. So what is this probability? Probability of success is 0.02, and suppose x is a random variable which counts the number of patient tested until the first side effect follows. So you will do the trial until you get a patient got the side effect. That means until you get a success. And success means a patient will get a side effect. What is the probability of that? It is 0.02. Right? So we all know that for geometric random variable, probability mass function is P of x is equal to k is equal to 1 minus p whole to the power k minus 1. So this many time you will have failure and then you will have a probability of success. We have discussed in this way only, right? And now what is p here? P is 0.02. What is k here? K is equal to 5. So just put it in the formula. Therefore, p of x is equal to 5 is equal to 1 minus 0.02 whole to the power 4 times 0.02. And if you just simplify, you will get the answer. So check it in your calculator and get the final answer. But I hope you understand. So whenever you have to do the trial until you get a success, so then it will follow the geometric distribution. I hope you understand. Now then look at the question number 18. A computer network experiences occasional failures. The probability that the network fails during any given hour is 0.01. If the network administrator monitors the network hour by hour until a failure occurs, what is the probability that the first network failure occurs during the 10th hour of monitoring? Now again, you have the success means whenever you will have a network failure. And what is the probability? Probability of success here. Question number 18. Probability of failure success means that your network will be failure. So P is equal to 0.01. And then again, you will do the trials until you get that network failure. That means again, it will follow the geometric random variable. The random variable x will follow, which counts the number of trial required to get a success, to get a network failure. So the question is probability that the first network failure occurs during the 10th hour of monitoring. So here you have to get that P of x is equal to 10, and where x follows the geometric random variable, geometric distribution, and then it is 1 minus p, 1 minus 0.01 whole to the power 9 into 0.01. This should be your answer. Okay, let me move to the few more questions. Look at this question. A factory produces items with 30% defect rate. What is the probability that the 8th item inspected will be the 4th defective item found? Now see here, that you have to, your probability of success is what? That you will get a defective item, right? Now here it asks that probability that the eighth item inspected will be the fourth defective item. So you will be doing 8 times trial, and at the times, like the eighth trial, you will get the fourth defective item, right? So that means in 8 trials you have to get 4 number of success, and exactly at the eighth one you got the fourth defective item. So exactly at the eighth trial you got the fourth success, where probability of success in each trial it is 30%. So P is equal to 0.30. 30 by 100, it is 0.30. So here suppose X is a random variable which counts the number of trial required to get K number of success. Which kind of distribution it is? Which kind of random variable X will be? Yes, we have discussed in our lecture. It is the negative binomial distribution. So X follows the negative binomial distribution. Right? So X is a negative binomial random variable. And we all know that for negative binomial random variable, what is the probability mass function? So the formula is P of X is equal to K, or P of X is equal to N. Maybe I'll write down N only, the way we have discussed in our lecture note, in our lectures. So P of X is equal to N. It is, that means in nth trial you have kth defective item, right? In rth kth trial, in nth trial you got the kth success. That means what? Up to n minus 1 trial you got that r minus 1 number of success. So how many ways you can do? It was n minus 1 c r minus 1, that was the formula for the negative binomial random variable, into probability of success to the power r into 1 minus p to the power n minus r, right? And where n takes which values? N takes the values as r plus 1 dot, 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 up to any number. Now the question says that the eighth item inspected in fourth defective item. So here n is equal to 8, and your r is equal to what? Fourth, that means 4, and your p is equal to 0.30. So put them in the formula, you will get the answer. P of X is equal to 8 is equal to n minus 1 cr minus 1. So it is 7 c3 0.30 to the power 4 into 0.70 to the power 4 again. So just put it in the formula, you will get the final answer, right? And a similar question in question number 20, a university is seeking 6 volunteers for a research study. The probability that a student volunteer is P, and the probability that a student volunteers like agreed, the probability that a student volunteers agreed, it is P, and the probability that a student decline, it is 1 by P. Then the question is, what is the probability that the university must ask 12 students before finding 6 volunteers? So therefore, what the university will do, that they will pick one student and ask that whether you want to be part of the committee or not. So the student may agreed or may decline. So agreeing probability is P, that means the probability of success is P, and probability of failure is 1 minus P, that means the student declines. Now here the question is probability that the university must ask 12 students before finding 6 volunteers. So it is again, if X is a random variable that counts the number of students required to ask to get K number of student agreed, then it will follow the negative random variables distribution, negative binomial distribution. And therefore where probability of success is P, and you have to do number of trial required is 12, and finding number of success 12th trial you have to get the 6th success. So in this case the solution will be, like, if we just directly write down the solution, P of x is equal to 12 is equal to n minus 1 c1 cr minus 1. N minus 1 means 11 cr. So you get the 6 success. So 11 c5 into p to the power, p means what? Probability of success. Here it is p only. P to the power 6 into 1 minus p whole to the power 7 minus 5, right? So it is 6. So this should be your answer, right? I hope you understand these problems. So I hope you will be able to understand which random variable will follow which distribution. So you can practice few more problems like this. I hope you enjoyed the video. Okay, we'll meet in the next lecture. Thank you very much.